Let's run through a quick introduction to Lab 20. So what you'll see in the demonstration video is the acid-base titration, and it's just part A that we're doing here. Titration is a really common technique in the laboratory. Basically what you're doing is you're going to determine the concentration of an unknown acid. In this case, it's going to be vinegar. I'd recommend taking a few minutes, read through the background for part A, a little bit of the calculations. There's more about calculations coming up. And again, we're skipping part B. Here's the experimental step. And I'm basically following the procedure here. For example, adding 5 milliliters of the vinegar, etc. The formatting of this looks different than yours. It's the same content. In the lecture video, I go into a little more detail about this. But basically, a burette is just a volume measuring device. It allows you to measure out very accurate amounts of sodium hydroxide in this case. And then down here, the acid sample, well, it's vinegar that we're looking at. There's an indicator in here called phenolphthalein. In an acidic solution, it's colorless. In a neutral to basic solution, it turns pink or fuchsia. That's how you know when to stop the reaction. Again, you'll see that in the video. Something that is very important in Timberlake is that she gives you example calculations for each lab whenever a lot of math shows up. Now again, the formatting is terrible here. I had to convert a PDF to a Word file to be able to do the notes on it. That's why you see such strange notation. Your lab manual will be much clearer than this. But when she's referencing the 4 and the 3 and the 2, these little numbers in parentheses, what she's referencing are actually lines in the report sheet. Let's look at that real quick. So here's a report sheet. It's these lines that she's referencing in terms of your calculations. We'll want to complete the pre-lab, and I'll put notes on this in a minute. A couple calculations down here. It's important that you watch the lecture video before doing this lab. The calculations here, titration calculations, are the most difficult ones to do in our class. And what you'll do with the video is you'll watch the video, fill in this data table, and then do those calculations. So this is good practice for the test that's coming up. And just like all of our labs, if we complete a particular part of the experiment, then we'll do the questions associated with the experiment. If we skip a particular part, then we are going to skip the questions associated with that part. So in this lab, we're just completing part A. Now in the video, what I've done, I demo trial 1, okay? And then for these two, I just give data in the form of images. So what you'll have to do is, actually for all of these, you'll have to measure the volumes on the images. And let's just talk about that just a little bit. So what I want to do here is actually walk through the process of determining the volume from a burette reading. And what you see here is the actual data from the experiment. So I'm going to give you the initial volume for the titration 1. You'll see this image in the video. These images are also posted on the PDF on Moodle, along with the volume measurements for the other 2 titrations. So from General Chemistry 1, you've experienced this to a degree, right? When water goes into a glass cylinder, there's attractive forces, pulls up the sides of the top of the water, okay? And that produces something we call the meniscus. And what I've done here, and I've done this in all the images, is I've highlighted the bottom of the meniscus. Honestly, this is easier to see than what you do in the laboratory. Now notice how the burette is laid out. It's different than a graduated cylinder, which we've all had experience with. You're starting at 0 milliliters up top, the volume is increasing as you go down. And what you have to realize is that each line there, as you're dropping down on the burette, it's actually counting up on the volume. So again, each line you're going from 0 to that mark is 0.1 to 0.2 to 0.3 milliliters, and then 1, 2, 3, etc., which you can't see. So this particular measurement, where that bottom of that red meniscus is, notice that it's just past the 0.4 milliliter mark. It's not quite to the 0.5 milliliter mark. It's a little bit more than halfway between those two marks. I would call this 0.47 milliliters, 0.48 milliliters. And that's the value that you would want to record on your report sheet. And you do this for each of the images. Okay, so you're going to be recording to the 100th position for each volume measurement in a titration. Remember, typical procedure for measuring from an analog scale, which is what we have here, you're going to estimate the next digit down from the markings that's on the burette or graduated cylinder, whatever you're using. And since each mark is at 0.1 milliliters, that means you can estimate the 0.01 position. Now let's go back to the report sheet and see how we put all this together to calculate the concentration of vinegar. Now once you've measured those volumes, then what you're going to do is you're going to average those. And what you do is to average, right, you add them together. And since there are 3 trials, then you're going to divide by 3. And then notice here you have to convert from milliliters to liters. And then this is the data that you'll use for the calculations down here. One other piece of information that's needed is the concentration of the base, which is that value. So you'll use this value for these calculations as well. Please show your calculations for this part of the lab. And again, I'm not going to do the calculation. I'm not going to give you examples here. You can look at this lecture videos for that. Test review also shows this. And again, a few pages back of the lab manual, Timberlake shows you how to complete these calculations also. And that's it. Thanks.